Hello friends, today I want to discuss with you a peculiar mechanical seal failure problem. Problem number 1, a hot hydrocarbon pump. Hot hydrocarbon may be hot naphtha, maybe hot beer, maybe RCO, running perfectly fine. There is no seal leakage. All of a sudden, you find there is a coke deposition backside of the gland plate, and after some time, all of a sudden, your mechanical seal starts leaking. Problem number 2, a caustic pump is running perfectly fine. You want to do schedule changeover of that particular pump. When you start your standby pump, it start leaking. But surprisingly, in previous occasion, when you change the pump, there was no seal leakage at all. And in problem number 2, also there you find a huge crystal in the back side of the gland plate. Now, problem number 3, a cryogenic product handling pump running perfectly fine, maybe liquid LNG or liquid nitrogen handling pump, and all of a sudden you find there is a icing at the back side of the gland plate, and all of a sudden mechanical seals start leaking. So, have you ever come across this kind of problem? What is the common in between three problems? There is a common issue, that is the deposition at the back side or atmospheric side of the seal chamber at the gland plate. So there is a deposition, there is a crystallization, there is a carbonization. That's why your seal may hang up and seal starts leaking. So what is the solution for this particular problem? And the solution is the API plan 62 is the only solution to cope up with this problem. So how API 62 help to solve this problem? That is the main discussion, today's discussion point. So now in API 62, what we did, we provide a flushing liquid. Flushing liquid may be nitrogen, flushing liquid may be DM water, or flushing liquid may be quenching steam. So we provide a quenching over there. So quenching medium plus the backside of the gland plate, stationary part as well as partially rotary part, and for prevent easy flow of the quenching medium, we provide a throttle bush over the gland plate, and finally the after quenching media, flushing the backside of the seal, quenching media drain out from this drain port. And for your information, the flushing should be at the top and the drain port should be at the bottom. That configuration should follow in case of plant API 62. So when you use steam, water or nitrogen, that is extremely depend upon handling liquid nature. If it is a hot hydrocarbon, we should use quenching steam. If it is a caustic handling pump, so as a 62 flushing plant, we provide DM water over there. If it is a cryogenic nature handling fluid, then we provide nitrogen over there. So for steam, if it is a hot hydrocarbon pump, so we want to flush this entire region with flushing steam. For this, we take a tapping from the steam header, and we take a tapping from the steam header, and after that we provide a steam trap and steam trap bypass. So first of all, we have to open this bypass valve, to drain out the condensate from that particular line. When you found there is perfectly dry steam, then you close this valve and open this needle valve. Why needle valve is provided in API 62? Because we want to regulate, fine regulation of that flow. That's why needle valve is provided to regulate the pressure, because pressure is very crucial for this 62 plant. Then we provide a PG to monitor the exact pressure of that flushing liquid. Then we provide orifice. Why orifice is provided? Because we want to restrict or regulate the pressure as well as flow. And main vital point for steam quenching API 62 plant is you should provide a dry steam to the mechanical seal. For that, steam trap is provided and the pressure. If the pressure is more, flow is more, then what will happen? That steam may cross this throttle bush and ultimately enter to the bearing housing, because in between bearing housing and gland plate hardly 20 to 25 gaps are there. So steam or high velocity condensate easily travel this path and ultimate contaminate your bearing housing oil. So your pump may fail due to because of lack of lubrication, or contaminated lubrication problem may arise and your pump may fail. So you should monitor the steam pressure as well as the quality of the steam in the API plant 62. And what should be the pressure? The pressure should be 3 psi or zero point 0.2 bar. So the steam pressure should not more than this. More than 3 pressure is not desirable. So its pressure should be less than 0 0.2 bar to enhance the performance of the seal. And during walkthrough or daily monitoring, what parameter you should check? Check the pressure of the particular steam quenching and the steam tap functioning, whether steam tap is properly functioning or not. So with the help of this quenching, in case of caustic pump, we provide DM motor, and DM motor will flush out the leakage caustic from this region, so there is no question of crystallization. Another benefit of this steam quenching is, if your product is very crucial in high temperature region and may auto ignition occur, in that case also the steam provide a blanket, a barrier in between atmospheric oxygen and your seal chamber. So if light leakage are there, so it will not auto ignited, because steam will automatically flush out this leakage material to the drain port. So this is all about API plant 62. I hope you get enough knowledge, you get lot of knowledge regarding the API plant 62. And if you are new to this channel, please subscribe my channel and share this video with your friends. For the timing, bye bye.